So after you long divide if necessary and factor the denominator, the third step is to find the partial fraction decomposition, the general decomposition. So if you have a factor in the denominator that looks like a linear function ax plus b to the m power, then you'll have m terms in your decomposition. So you'll have a1 over ax plus b, a2 over ax plus b squared, all the way out to a sub m over ax plus b to the m. So in other words, if this is a squared, you'll have 2 terms. If this is cubed, you'll have 3 terms, and then so on. And then if you've got an irreducible quadratic, ax squared plus bx plus c to the m power, then you'll have m terms, so the number of terms matches the power again. But now we've got in the numerator a1x plus b1, a2x plus b2, and so on. And these constants here, a1, a2 up to am, and b1, b2 up to bm, those are the undetermined coefficients. So they're just constants that we want to try and figure out. So let me illustrate with some examples here. This will hopefully help. So here our denominator is already factored. We've got 2 linear factors. So we're going to have one term that comes from x plus 2 to the first. And we're going to have another term that comes from the x minus 1 to the first. And we're going to have constants in the numerator. So if it's a squared, you've got a linear in the numerator. If it's a linear in the denominator, you just got a constant in the numerator. So I'll call these constants a and b instead of using the subscript notation. Well, what about x minus 1 squared? Well, that x is a first power, so we'll have one term that's got x in the denominator. And then we got x minus 1 squared. So we're going to have one term that's got an x minus 1, and we're going to have another term that's got an x minus 1 squared in the denominator. Now these are all linear, so we're just going to have numbers in the numerator. Let's call them a, b, and c. So this will decompose here. This expression will decompose into something that looks like this. And we just want to find the a, b, and c. And then this one, we've got irreducible quadratic. Second power, so we're going to have 2 terms. We're going to have an x squared plus 1 in the denominator of the first term, and an x squared plus 1 squared in the denominator of the second term. Our numerators are going to be linear. Power is 1 less than denominator. So I'll call this first numerator ax plus b, and then the second one I'll call cx plus d. And the reason we're setting it up like that is because all of these terms up here, well, these 4 anyways, if you integrate those are just log functions. This one's going to be a u substitution, u is x minus 1. And these guys here, well, this is a log function because you've got, here's your function and its derivative on the top. And then this one, this will be a u substitution. Here's your function and its derivative. And again, these two are equal. So we're finding the constants that will make these equal.